Welcome back, everyone, from lunch. I'm Billy. I'm the speaker presenter for this room today. I'd like to bring to the stage Josh Schwarz from Airlock Digital, talking about how to harden your operating system. Please make him feel welcome.
Cool, thanks Billy, and thanks everyone for coming. As mentioned, today we'll be walking through trimming the fat or kind of cutting down your environment. Attack surface reduction is a fancy term for that, right? So we'll work through some of the what's, the how's, the why's. So Joe, just to introduce myself, as Billy said, I'm currently working for Airlock Digital, who is an Australian company working on allow listing or app control and using that to help our customers kind of, first of all, get control over their environment, but then to elevate their security control and implement some of the stuff we're going to talk about today. So my background's in defensive security, incident response, forensics, some SOC work. I'm a huge advocate for prevention techniques and purple teaming, and that's kind of the lens we've taken today in this presentation. And a lot of my view of this, right, is based on writing detection rules in Splunk and really wishing that I could do a lot more and actually kind of take action against some of this stuff. And I suppose just to set the scene as well, the experience I've had with Airlock customers is the lens that I've used to kind of brought along today to walk through some of this stuff. So just at a high level, we'll walk through the ecosystem and kind of set the scene. We'll walk through LOLbins or living off the land attacks, kind of talking about the what, the why, and the how we can prevent them. And then we'll talk about defensive strategies, tooling, what you guys can kind of take back to your organizations. So bear with me here. I just want to set the scene. So Windows 10 long-term servicing branch, or LTSB. So this was released back in 2015. This is hopefully the build everyone's running as their golden image or MOE or SOE. It's entering its end of life cycle. So it's about 10 years old now. So over the next 12 months, this is going end of life. So hopefully everyone has fond memories of Windows 10. But yeah, hopefully everyone's also updated. So I'm bringing this up because we're going to use Windows 10 as a bit of a baseline for some of the conversation over the next few minutes. So Windows 11, this is just, again, I'll explain in a second, but this is just, again, generic 23H2. Probably should have redone this with 24H2 now. But again, this is just pretty bog standard Windows 11, right? So this is, again, hopefully what you guys are running now or thinking about starting to run. The LTSC or LTSB has just been released of Windows 11, and I'll talk about why that's important in a second. But I just wanted to start today with a comparison of kind of what we have, or hopefully have, and what we will be working towards. So that comparison, right? The reason this is such a hard problem to solve and kind of get control over some of our endpoints, this is just a rough count of the files on an operating system. So Windows 10, the cut down or the long-term servicing branch, 82,000 odd files in a few kind of key directories there. So program data, program files, C Windows and C users. And just to clarify as well, this is very much not a scientific experiment. We took some ISOs off Microsoft's site, installed them, opened File Explorer and did a count, right? But we see Windows 11, right? Big jump, lots of new features. We see about 40-odd thousand files that were introduced in between those two builds, right? Now, some of these we know about, we know what they are, we can tie them back to specific features, but I don't know anyone, probably not even inside Microsoft, that can speak to every single one of those 40,000 files, what they do, how they got there, why they're important, do we need them or not. And interestingly as well, on Windows 11, I'll call it consumer build, you can see a lot of the guff is actually in program files, right? So some of this stuff will be your Candy Crush and whatnot, could be some drivers and stuff, but yeah, it's a lot of kind of garbage. Cool. So I mentioned the Windows 11 LTSC. That's just come out in October. It's based on 24H2 feature-wise, is my understanding, and it's still relatively new. But again, if you've got a chance, and again, we'll go through it, but I would be looking to move all your builds across to this. And why should you be doing that? Well, if we do that same comparison now, again, Windows 11 to the Windows 11 long-term servicing build, you can see there's still a lot of new features, right? There's still 20,000 odd files that have been brought into the environment with that upgrade. But if we look at the change, right, we've gone from a 40% additional files being brought in down to 20, right? So there's still new features, but we've got a bit more control. And again, as I said, we're not going to know the 20,000 files versus the 40,000 files. No one knows. I hope no one has to know the difference there. But again, it's more likely I'm going to be able to make some progress with 20,000 files than 40,000, right? I've halved the work. So we can get a lot of quick wins just by being smart with the base images, and thankfully you'll see some huge reductions, particularly around that program files directory compared to that Windows 11 piece, right? So that's kind of more on the desktop side. If you're a sysadmin kind of running Windows servers, you've likely seen Windows Server Core. This is great. Microsoft is great at writing docs, but there's a lot of stuff in there, right? It's very easy to miss small features, not really understand the implications of what some of this stuff means. So Windows Server Core is cut down. Again, I'm definitely not saying don't deploy it, but I am saying, it's worth doing some investigation. Don't assume just because you're running Windows Server Core that these new features aren't going to come out. Microsoft seems to have this love at the moment of deploying stuff straight to prod and kind of not letting you opt into it, kind of being on by default. So you'll see here a couple that we've called out from a particular release, right? OpenSSH and the ability to kind of zip and unzip files natively. Great features, but a little bit scary to think that this could be running on some of your critical infrastructure. To that point, I don't want to give you the wrong idea here. I'm not saying new features bad, never update, run the same build forever, but there is a balance to be struck. Having utilities at our fingertips as sysadmins is great. Not having to install PuTTY to SSH across into a box is a huge win. I use that all the bloody time. But also, an attacker that got access to the box now doesn't have to bring tools in, right? So where I might have been able to catch a PuTTY download on a firewall, I now don't see anything because they're on the machine just running these tools. Same goes for, again, the compression, right? They now don't need to bring in WinZip or WinRAR or something. They can just kind of run and go. So these kind of toolings that can serve kind of those both purposes, this is what I'm referring to when I mention LOLbins or living off the land binaries. They go by lots of different names. But these are the components of the operating system that exist in that grey area. They're not bad tools, but they can be abused intentionally or unintentionally by malicious actors or an insider threat or something like that. And it's really hard because AV and EDR struggle here. How can they signature this? They don't know if this is good or bad. Again, a tool that's been built to download a file, downloading a file isn't a bad action, but that file that it's downloading could be malicious. And so because they live in that world, it can be a bit of a struggle for them to build good signatures. So they're really relying on those behavioral detections. And with those behavioral detections, we are seeing huge improvements, right? But it's definitely not perfect. So again, it is important. So I wanted to kind of set the scene here and show what these LOLbins look like in the real world. So this is an attack that was performed by a threat actor called Vault Typhoon. And this was a great write-up. Some of my example ones are getting a bit old now. But again, the tools, the techniques, the attack chains that we're seeing haven't really kind of fundamentally changed. So you can see with this threat actor, they've changed together multiple of these kind of behaviors or living off the land binaries. So again, every single step here was an intentional feature built into a tool, but when it's chained together, we can see that malicious actions were able to be taken, right? So we're seeing things like NTDS, util, netsh, WMIC, xcopy. In this attack, they pulled down, I can't remember if it was WinRAR or 7-zip, but something like that. Another example here, this is an Astaroth attack. This whole blog post is really amazing, and again, should definitely be a must read for you. It is from 2019, but again, we're still seeing the same stuff. So this attack it's almost comical, right, in the level that they've had to go to get their code to run. So I really want to flag here, an awesome thing to note is that EDR is working. This is what they're having to do now to get code to execute on endpoints. That also comes, with the downside of we now need to be running EDR. If your EDR isn't on, running and configured correctly, these attack chains are just going to sail straight past. So in this attack, we're seeing, again, WMIC that's downloading files. We're seeing bits admins downloading other files. Cert util is doing some decoding. AUSCERT2025 is executing DLLs and injecting into processes. We're seeing user init, which is spawning a process to be injected into. And we're also seeing a lot of scripts, right? So batch scripts and Java scripts. I just want to flag as well, we hear a lot of people talk about fileless malware, like it's this big scary thing. But often it looks like this kind of under the hood, right? It's not fileless, there is stuff happening. It's just not stuff we traditionally think of. You know, there's no Cobalt Strike, you know, sitting on disk that we can come through and rip off with forensics. So a lot of the time it's just these kind of JavaScripts, bats, DLLs that are kind of being pulled down, run, deleted straight away. And they're often being used, loaded or worked with legitimate methods like the load library functions in Windows. And I just want to flag as well, as an endpoint vendor, this is really bloody hard problem to solve. So every step in the chain, again, is not malicious. So we can't signature them. It's just tools doing what they've been built to do. So if you've had the pleasure or the pain of running procmon on some of your machines, that kind of shows you what's happening in the background on your machine. File read, writes, network access, driver loads. It goes crazy. You open that for a couple of seconds and it just sits there scrolling, right? So EDR vendors and security vendors, we're kind of subscribing to a feed like that and trying to make sense of it. Again, there's stuff in there that makes perfect sense. We block it straight away because it looks bad. But there's a lot of stuff coming through that, again, we're having to chain stuff together and watch stuff over time, and it can be a real challenge. Then you add in the fact that some of these behaviors are potentially non-malicious, some might be sysadmin, and it becomes a really difficult challenge for us to solve. Cool, so even though there's lots of these different attack chains, there's a new CrowdStrike bypass that's out every week that looks something like those ones. There's a lot of commonalities between the attacks. So we're seeing heavy use of LOLbins to get around those behavioral detections. We're seeing huge amounts of script usage. And again, attackers are assuming EDR is running when they're building these runbooks. So again, we have to be responding to that. And as I mentioned before, you know, we are seeing in the vast majority of attacks, we're seeing something touch disk or something that we could catch, block, triage. I don't want to get sidetracked because I could do a whole standalone presentation about Sysmon and how amazing it is and how everyone needs to have it turned on and plumbed into the seam. But definitely go and look at turning on telemetry from Sysmon if you've got the capacity, because you get some great kind of visibility there. One to call out in this kind of context is that event ID 23, which is the file deletion event. So again, if anything's ever kind of come down, touch disk, you will see that deletion event. And this can be, again, a great way of watching attackers clean up their own mess after they've been in. But again, if you want to chat Sysmon, come past the booth and I'll talk your ear off. And actually on Sysmon, before I do sidetrack myself, if it is interesting to you and you want to kind of start on that journey, there's a guy called Olaf Hartong. I think he's from the Netherlands. He has an amazing Git repo that can help you kind of get up and running with that. Again, Sysmon sees a lot of stuff like that procmon piece, and so you can refine the rule sets and get some pretty good outcomes really quickly. Cool. I want to note as well that all these attackers are following playbooks, right? A lot of these guys aren't sophisticated, amazing attackers. They've got one smart guy that finds a CrowdStrike bypass, turns it into a script and hands it off to the next guy, right? And so we're seeing the same LOLbins used over and over again. And again, the huge benefit for us here is that all you have to do is stop one part of that chain, trip it up. We now have an alert we can respond to. We've now prevented the attack from kind of landing here. So in terms of some of the ones we're seeing most commonly, RunDLL32, MSHTA, MSBuild, WMIC, RegServe32, and BitsAdmins. Really annoyingly, these are also the ones most commonly run by your internal teams. You know, if you've got developers, MSBuild's how they're probably compiling their code. You know, WMIC was used for a very long time and is probably still floating around in your environment, in your internal tools and scripts and stuff. So I'm going to spend a fair bit of time now talking about how we can actually kind of do this, but it's really important that we don't just block them blindly, because again, a lot of this stuff is being legitimately used by parts of your business, parts of your tool sets already. We really need to look at the telemetry, identify the common use cases, and cut out the rest that kind of aren't being used legitimately in our day-to-day behaviors. It would be really nice to just delete the file and yank it, but yeah, unfortunately, I haven't seen an environment that is able to do that. Insert the mandatory Microsoft whinge. Microsoft know that a lot of this stuff is problematic. They're not fast to move, though. Again, one of Microsoft's big strengths is their backwards compatibility. One of their big weaknesses is their backwards compatibility. So this is a great example. WMIC has been deprecated, and they've rebuilt the PowerShell commandlets. They've done all that sort of stuff, but that was in 2016. It's only January of last year that they finally turned it off by default. And again, I wouldn't be surprised if a lot of people have turned it back on, because that was easier than rewriting your scripts and updating all your tooling and whatnot. But again, this is a 10-year cycle of knowing that there's this piece of code out there that's potentially being abused, that they've tried to end life and then just couldn't kind of rip it out of the environment. So again, Microsoft's great at telling us about it, but not great at taking action. So again, go read all the blog posts, go and read the docs, but then you're going to have to take your own action. We can't rely on Microsoft to do this for us. Cool. So hopefully at this point, we've got that we need to do what we can to reduce the foundational level of our environment, right? Get rid of as much stuff from our machines from the get-go, or block the behaviors, and that will cut out entire classes of attack, right? If you think about like the MITRE ATT&CK framework, you can come and drop out entire kind of columns at a time. So, you can do things like, if you're not using a feature, just disable it. If you're not using a LOLbin, find a way to block it. Definitely go and look up the attack surface reduction rules in Defender. Go and turn these on. They're great. Again, Microsoft's built them, so they're reasonably safe to turn on. And use this as inspiration to go and investigate your own. What behaviors does that inspire? Adobe Reader doesn't need to be making internet calls. Are there other apps that you can go and put similar filters in place for? I also encourage you, go and read up on the Microsoft recommended block rules for LOLbins and for drivers as well. Again, Microsoft published this stuff going, here's a list of these problematic apps, and then leave it up to us to go and do something about it. And recall at the top, right, the difference between the consumer builds and the LTSB builds. Go and run those builds or a server core, and we're going to get a huge win really quickly. So doing these things will provide the best bang for buck in terms of strategy. So again, if you think of those attack chains, all we need to do is break one step. Block the JScript call, block the WMIC, block the network connection that's pulling the file down, and that will trip up that whole attack chain. And again, based on what we're seeing in the real world, you break the script that smart guy wrote for the guys, they're going to move on to the next target. They're not going to sit and try and tweak and find a different LOLbin to replace the functionality. And the cool thing from my point of view is we can actually prevent attacks rather than trying to signature them, trigger a SIEM alert, quarantine a machine, and then rebuild it, right? We can actually just stop it from running. So to do it, go rebuild your golden images, cut down the OS. You can use EDR to build those custom block behaviors. Allow listing is a great solution to handle this. But the key thing, as I just mentioned before, right, is we need to be able to proactively monitor and tune the rules as we go, so that we don't kind of stop Windows updates from being pulled down or something like that, something important. So to do it, we're going to have to make sure that we can see what's running, right? We have to, of course, see the behaviors so that we can then tune our rules and scope it to be appropriate. So these exemptions could be things like, adding an exemption for a trusted parent process. Maybe you have a monitoring tool that's still relying on WMIC. Again, my normal users don't need to be running it, but it's easier for me to write an exemption than it is for me to go and replace a monitoring tool. It might be scoping it to particular user groups. Maybe we can say admins are allowed to take a user behavior, but if a normal user comes along, that's not going to be allowed to run, or if system comes along, we're not going to let that do it, and you can refine that as appropriate. But ultimately, you just need to watch the data. Again, as someone that gets the pleasure of seeing this data flow through all day, every day, the data tells you pretty quickly what rules you need to tune and how you should best tune them. It's also really important, and as a security guy, I always forget this step, but we need to communicate. Again, when we're removing functionalities or stopping stuff up front from running, it's great, it's a great outcome, but we need to make sure people know what we're doing, how we're doing it, and how to get around it. Do we have an exemption workflow? Can someone modify the rules? Who's allowed to modify the rules or give approval? Again, because a lot of the time, these tools are sysadmin troubleshooting tools. not something I want running day to day, but I do want the ability to, turn it off for 10 minutes and run an update or something like that. Only once we've seen the data, scoped the rule sets appropriately, worked out how we're going to kind of handle the edge cases, only then can we actually look to move those rules into enforcement mode. So as a bit of a worked example, I mentioned the WMIC before. It was meant to be end of life in 2016. So again, would be nice to walk in and just remove it, right? Block it from running. But again, in my experience, we're seeing lots of people still running it. But how many users are running this? How often are they running it? Is it being invoked once a week or once a day? What's going to break if we turn this on? We see all the time, lots of old tools are still relying on it, old scripts. I found on my home machine that my bloody RGB fans on my gaming desktop are relying on WMIC to change the color if the CPU temperature goes above a certain number or whatever, right? I need that behavior so I can scope my rules appropriately, right? And it also gives you a chance to decide what the best course of action is. So again, if this is your boot script or an internal PowerShell that you guys are running, you can go and swap WMIC calls to the PowerShell commandlet, right? Or you might be able to go and chat with a vendor and run an update, ask them to fix the root cause. So again, with lots of different potential solutions, and being able to see the data will give us the chance to choose the right one. So use your logging and monitoring to review and tweak. In my experience, a lot of these cores, like something like WMIC, it's normally a couple of parent processes. The best I've seen is about 5 different parent processes across your business. And again, that we can allow those behaviors and block the rest. I've spent a lot of time talking about executions on endpoints because that's the world I live in. But if some of the tools and techniques are kind of out of reach, or you don't know how you do it, you can start with some real basics, right? Use your Windows firewall, turn on your EDR firewalling. Do some basic things like scope the system account to only be able to access no internet. Maybe scope admins to just be able to reach local subnets, particular apps and tools. Bits admins might be being used to pull down updates. Well, we know the IP addresses it's going to be pulling from, right? It shouldn't be calling out to random Dropbox IPs. So again, we can get some quick wins here by turning on the firewalls and again, tuning those as appropriately. Cool. So in terms of foundational capabilities, I'm probably starting to sound a bit like a broken record, but to be able to monitor, scope, and block, we need to start with that visibility piece. So EDR is great for this, allow listing is great for this, sysmon or even endpoint logs just flowing through to a scene that you can kind of scroll through, that should be a good place to start and get you that level of visibility, at least initially. We also need the capability to actually block those file loads from happening. So likely you've got this capability built into your EDR tool. That's probably where I would start looking. You can also, again, come and talk to an allow listing vendor, turn on WDAC, turn on app locker. That will give you the ability to, again, scope those rules and block some stuff. But however you do it, you need to make sure that you've got the ability to test and refine and see the feedback cycle. Again, we add an exemption. I want to see what effect that's going to have. Do I have another exemption that maybe runs once a week instead of once a day? And again, you can use that feedback cycle to refine those rule sets. As nice as it would be, we can't just delete the files. A lot of these are written by Microsoft. They're part of the base image. And when you run Windows updates, they'll repair the app, put the file back, or attackers will bring it in. They'll notice it missing. They'll pull it down themselves. It'll be a legitimate Microsoft file, code signed. It looks legitimate. It'll come straight down and end up on that machine and be allowed to run. Cool. So to wrap up, I've talked about a lot of different things and a lot of different techniques and how we can do it. But my ask of you is to go and remove anything that's unused or unnecessary in your environment. And again, feel free to start with the quick wins. If you aren't using a feature and you know you're not using a feature, disable it with DISM, GPO, Intune, whatever you've got in your environment, right? Microsoft, for all their faults, are actually really good at giving us the tools as sysadmins to do what we want to do. Where possible, use a server core or a minimal Linux ISO as your kind of base. It's a lot nicer, a lot tighter environment if you can start with a minimal install and add stuff in, because you then know what you've added in. You're not kind of hoping that the vendor's done the right thing. And again, on those endpoints, hopefully you haven't done your Windows 11 upgrade yet, and you can go and use the Windows 11 LTSB. or you can migrate to that. Again, that'll give you some good quick wins. In terms of the LOLbins, there's some really great resources both for Windows, Linux, and Mac. And go and read the blog post. There's a few kind of Git repos and websites. The LOLbas is one of my favorite ones. It shows you examples. It talks about how you might block it, what the risks of leaving that tool running are, what the attacks can be used for. I believe they've updated it now to map to MITRE ATT&CK framework as well, which is really cool. So yeah, if you study up on those, you can kind of look at what you care about the most, see if there's any quick wins, and pull that in. If you can only pick one reference source, go and do the Microsoft recommended block rules. There's a reason that these are included in the Essential 8. It's because they work. Again, Microsoft don't publish these rules for fun. They know they've got these gaps, and that's a great place to get some easy wins. And again, if that's as far as you go, you'll get a huge risk mitigation with those. So those rules are available. The documentation page is called Applications that Bypass WDAC, or Windows Defender for App Control. But that has a really nice XML in there that you can kind of pull through and triage and convert into Airlock or CrowdStrike or S1 kind of block rules. There's a link here as well to WinUtil. So this can serve as a great inspiration for how to clean up golden image. And you can rip commands from there and kind of use that as again, some quick wins. And look, if nothing else that you take away from here, my ask is that we remember prevention, right? You're never going to be able to keep up with all the new attack methods. Every day there's some new novel attack, there's some new vulnerability, and it's just unfeasible to think that we can stay on top of it. And ultimately, it's what we're paying EDR vendors for, right? They do this as a job. They have hundreds of people kind of doing this all day, every day. So if we focus as defensive security teams on the real kind of foundational controls, removing features, blocking the things we don't want, don't need, and attack surface reduction, we are significantly going to raise the bar for malicious actors. And we see time and time again people that come, knock on the door, try run their favorite bypasses, it doesn't work, and then they go away onto the next organization. Now, if you bear with me for 2 minutes, I have to earn my salary here. In Airlock Digital, we've got a bunch of these, we call them block lists, but that's the blocking of the deleting off the land binaries. We've got them pre-built, mapped to MITRE, Microsoft, and the LOLbas project. And so we can pull those in. Again, we can put them in a soft blocking mode, see the real-time feedback, scope the rules as appropriate, and help you kind of restrict some of that stuff. So I'm not sure how clear it is on the slide here, but again, there's some real basic ones. Hey, I want to stop this app from running. And there's some more nuanced ones of, hey, I need to allow this in these parent processes for this service account and that sort of stuff. So if you want to know more about how we kind of tackle it and the sorts of things you can do in your environment, we do have a booth out in the vendor hall, and you can swing past and we can have a big chat. Cool. Thank you very much.
We've got about 10 minutes for questions, if there were any. There's one. The mic will allow everyone to hear.
Back to that WMIC slide that you had up, you had the command switches. Was there particular commands that we should use to see WMIC usage? Like, I wasn't quite sure what you were saying there.
So WMIC, we normally just see the binary running. It's an exe under the hood. So again, if you've got sysmon, EDR, something like that, you'll see it running just in your telemetry. So.
Anyone else? Hands? Hands? No hands. All right. Can you please thank Josh?
Thank you.